All right, so in this video, we are going to talk about actual momentum problems where you actually have to do some calculations. Some people get scared of calculations. Hopefully at 151, you're not too scared of doing calculations, but this video is going to be relatively simple. We're just going to start out with the basics. I have a mass here, and we'll make it 5 kilograms, moving to the right at 3 meters per second. What is the momentum of this object? Now, I haven't given any context, I haven't given a planet or anything like that. All I know is this object's moving at 3 meters per second. I don't care about gravitational forces or actually any forces acting on it. As far as we know, this thing is moving at a constant velocity in the middle of space, actually beyond the edges of space. We can get into that debate later about what defines space. But we have this 5 kilogram mass moving at 3 meters per second. Now, the formula for momentum is mass times velocity. And so we need to be able to know what the velocity of this is. Now it's relatively simple. It's moving to the right, but it is a vector, and we need to somehow describe the direction it's moving in. And so we do what we do for a one-dimensional problem is we just define a positive direction. I'm just going to say to the right is positive, and therefore my momentum is 5 kilograms times 3 meters per second. Now it is a positive 3 meters per second. I don't have to put the plus sign there because it's understood in math. If the sign's not there, it's understood to be positive. However, I'm emphasizing the fact that this is a vector. And so this ends up being positive 15 kilogram meters per second. Just multiply the units, kilograms times meters per second. If you're still a little fuzzy, I hope you're not at this point, but if you're still a little fuzzy, I'm doing kilograms times meters per second. Basically, we're multiplying fractions here. And so we end up with kilograms times meters over seconds. Now, for whatever reason, the powers that be have not come up with a single word unit for this. Like a kilogram meter per second squared is a Newton. A kilogram meter squared per second squared is a joule. A kilogram meter squared per second cubed is a watt. But a kilogram meter per second, they don't have a unit for it. So we have two choices here. One, if you recall that force times time is equal to the change in momentum. And if you don't recall it, that means you probably haven't watched the other video or weren't paying attention at that point. If this equation is true, the units must match. And so momentum, we have a kilogram meter per second. And so that should, over here in SI units, should match it. So the SI unit for force is Newton, and for time is seconds. So you could just write the unit as a Newton second, and that's perfectly fine, perfectly legitimate. So a lot of people just prefer kilogram meters per second because it comes right out of the formula. The other alternative is to make up your own unit. Now, when you're making up a unit, there's a big rule here. One, you have to define it, and it cannot be a unit that's already being used. You cannot use a capital N. If your name is Nancy, you cannot use capital N to honor yourself because capital N is already being used. Lowercase n is used for nano, so that's out. Lowercase s is used for seconds, that one's out. Uppercase s looks too much like the lowercase s, so don't stay away from that too. The unit that I prefer to use for something like this is the Descartes, what I call the Descartes, because Rene Descartes did some early work in momentum. Matter of fact, I think he's the one responsible for P being used. This is Descartes as in I think, therefore I am, and also from which we get Cartesian plane and cartography, I think. No, I could be off on that one. So the Descartes I use for a capital D, and I define it, that's with the 3 bars here, means I define it as a kilogram meter per second. Now, the deal with dealing with Descartes is you have to define it every single time. Now, if you're going to use this for an entire test, then you can just write it at the beginning of the very test, and that will cover the entire test. If you want to use it for an individual problem, then you just write it for that individual problem. So this is known as, if you put it at the beginning of the test or the quiz or at the top of the page, this is known in computer science as declaring a global variable. If you put it on the individual problem, this is known as defining a local variable. If you haven't had the computer science experience, don't worry about it. That's just a side note. So So I could write this as, with this written here, as 15 Descartes. This is perfectly fine because I define it right here. Now, if instead of, as I start to erase the board, if I erase this first, this is now wrong because Descartes is not accepted anywhere. So it is wrong because I haven't defined it on the board right here. So let me put the definition up. I'm going to put it in the corner because I'm going to use Descartes more than once. So I'm going to define a Descartes to be a kilogram meter per second. And that should cover the rest of what I'm doing on the board here. Now, problem number 2. I have a 8 kilogram mass going to the left at 4 meters per second. What is its momentum? So what I'm going to do right now is then I'm going to keep my same convention here because the problems I'm going to do in the next video, I'm going to have them run into each other. So right here I'm going to go ahead and say to the right is positive. And so my momentum is mass times velocity. We'll just start out with that. My mass is 8 kilograms. And I know it is mass because it has units of kilograms. Kilograms is a unit of mass. It is not a unit of weight, despite what the biologist might tell you, times negative 4 meters per second. And so my total momentum is negative 32 Descartes. I was about to say kilogram meters per second, but we have a shorthand for it, Descartes. And so this is a positive and negative momentum. If, let me do a third one right here, since we're on the track. So if I have a 4 kilogram object with a velocity of 5 meters per second I hat minus 3 meters per second j hat, what is the momentum? It is the exact same process as we did before. So it is mass times velocity, so P is equal to mass times velocity, which is 4 kilograms times 5 meters per second I hat minus 3 meters per second j hat. And then you just distribute, because I have something multiplied by a binomial term, or I think it's, my language could be a little bit off on that one, times a binomial, there we go. So you distribute, so I get 20 Descartes I hat minus 12 Descartes j hat. The math is just 4 times 5, and then 4 times negative 3 to get negative 12. It is also legitimate to write this as 20 I hat minus 12 j hat, and then parentheses around the whole thing, and then the units tacked on at the end. This is also an acceptable answer. So that is just the basics of how to find momentum. And I will stop it here.